Hi guys, welcome to Tech Geek. So today we are here again sharing the Leetcode daily problem solution. So this time the Leetcode problem was a hard one. Basically a binary tree question where you were supposed to find the binary tree number of cameras, that is the minimum number of cameras. So before beginning with the solution, I'd like to request you all to please like, share and subscribe. And yeah, if in case you want me to share any particular interview experience, test, or in job openings for any relevant position or any particular solution or anything you want to know from me, please mention in the comment. And yeah, we have one sheet that's for the preparation of interviews that is also shared. In case you need that, ping me in the comment box. I'll be happy to share that with you. Okay, so let's see. So the question says is that you have been given a binary tree. So we'll be given a root for the same. We need to install cameras in the tree nodes where each camera at the node can monitor its parent, itself, or its immediate children. Okay, so that is the condition that we have been given. We need to return the minimum number. So this is a constraint that we need to check the minimum number of cameras that are needed to monitor all the trees. So there we have a tree 2. So they have given us a tree where they okay. So here we have these nodes. Camera could be here. If it was here, it will cover this particular position, but not these two. Now coming here, if it is here, it will cover itself, its parents, and the children. So I guess for this particular, we all know that one would be enough. So while looking at this, we know three things. Okay, let's okay, so I'll be using DFS for this. That's the very first thing I'll tell you. Let's say we have these trees. Okay, this is kind of a road. Now what is the condition that could be there? If this is a parent and if this has camera, okay, then obviously these two will be covered. If in this case this is not having camera installed and this is having a camera installed, then it will cover itself, its parent, but not this, right? So for this we'll need to have another camera. So that's the condition we need to check. So now let's look how we will. So these are two basically different things. Yeah. Now for this particular question, let's see, this is the first one as I explained initially. So what we'll do, we'll check the tree node. If the root, wait, I'll just need this. Okay. So what is the condition that we'll take is if the root is null, we'll be passing the tree, will be having the root. So if it is null, then obviously we don't require anything. Okay. Now we'll check its left child and the right child. Okay. We'll check for the left child and the right child. If both of these are there. Okay. So first we have created few constraints. We'll keep a check solution. That's you can say check. Okay. First, let me get this again. Okay. We'll make three constraints for this. We have three values. If the check particular function returns -1, that means there's no camera and we really need a camera. Okay. If it is 0, 0 means it has a camera, that means it is already being covered up. If it is 1, that means it does not has a camera but it is being covered by the child or the parent camera. Okay. So these are the three things we know. Now what we'll do the TFS part for this tree, for the same. Okay. What we'll check is, this is this one. Yeah. We'll check for the root. If it is null, we'll return 0. Now we'll check for the left and right child. So for left child or the right child, if it gives -1, that means it requires a camera. Then what we'll do, we'll increment the camera by 1 and let's say we return 1. Okay, for the particular function to keep a track of this. Now let's say if it was the either case. If it was not -1, if it was 1 for any of these or both of these, because we're using or, then in that case what we'll do, we'll return 0. That means that it's already being covered up. If not these three, then we'll return -1. That means it needs a camera. Okay, so this is what we require basically. This is the main funda that we'll be using. Okay, now let's check for this. If we send the root, right, we sent it here, it will check, is the root null? No. Then it will come to the left child and the right child. Right child is null, so obviously there is nothing to be done. For here, it will check again. If anything is there, no. Right child and left child, again, if it is 1, 0. So for this particular, it will increment the camera, that's +1, so we'll get 1 camera. Same comes here. It will first come below for the left child. Again, here for this one, it will check for the left child, there's nothing. It is 1, so it will return 0. For this, the increment it by 1. Now it will move up to the upper one because we have called the left child and the right child recursively. So obviously we'll see this. For this, incremented by 1 but reduced by -1. So again, this will have the camera. Okay. Let's look at the code. So what we are doing, as I said, we'll check. So here the check function is this recursive function where we are checking whether the root is null, and then we'll keep it up. Like we'll check whether the left child and the right child are -1, then return 0, increment the camera. If not, then do the same. And here we are checking if it is -1, then we'll increment, that's requirement, then we'll increment the camera here too. Make sure this camera variable is global because we are incrementing it here and here. So for this particular solution, we have order of n as the time complexity, and the height of the tree will be the space complexity, order of h. Okay, this is the time complexity and this is the space complexity. So in this case, if there are any doubts on the solution, please let me know and ping in the chat box. Thank you so much. Please like, share and subscribe to Technique.